Okay, so we just talked about scientific notation. This particular question, we're going to look at scientific notation and significant figures. Normally they go hand in hand. There's not much use taking a number that's got like 24 digits in it and making it times 10 to the power of something and still having all 24 digits. You haven't actually made it that much easier to read. So what we have a tendency to do is we deal with significant figures. Now, the whole thing about significant figures is they are an approximation. But when you think about it, if I'm trying to work out the distance from here to the sun, I don't need to find it to the nearest centimetre. Right? Apart from anything, it changes every millisecond. So what we do is we use significant figures to get a close enough approximation that's enough for what we need. Okay? When someone says it's 2:45, it's probably not exactly 2:45, and realistically, by the time they finish the sentence, it's no longer exactly 2:45 anyway. We use what we call significant figures to say basically it's close enough. You don't need any closer than that, realistically. That's why people will go, no, it's 2:44 and 18 seconds, just to know the crap out of 95% of people. And it might not be exactly 95% of people that it annoys, it could be 94.82, but we don't care. All right. So, imagine you were actually looking at a star. Now, let's say that this star is 5.9630 light years from Earth. Now remember, light years is a measure of distance, not of time. It is the distance that light travels in a year. Okay? Unfortunately, none of you guys are doing physics, so it's not something you'll come across regularly, because let's face it, in biology you do not deal with light years. A light year is the distance that light travels in a year. Now, to be able to work out how far that is in, say, kilometres, if you had to work it out in kilometres, then the thing you need to know is how far does light travel in a year. You need to know what the light year distance is. Buzz Lightyear. So a light year is this, 9.4607. They would give that to you in the question. You know how I can tell they'll give it to you in the question? Okay, so that's how far it is. Now, if we didn't write that in scientific notation, this is what you'd end up with. That, kilometres. So that's how far light travels in 1 year, in kilometres. It's quite a long way. Just to put that in perspective, how long does it take for light to get from the sun to the earth? 8 minutes. 8 minutes. 8 minutes and 40 seconds to be precise. Ish. Yes, that's correct. If the sun blew up, we wouldn't find out for 8 minutes. But the whole point is with astronomy, you're actually looking back in time. We're talking about a planet or a star that is 5.9630 light years away. Okay? That means if it blew up, we wouldn't see it for 5.9630 years. That's how long it would take for the light to get here. Oh, I'm going to have to give you an example, aren't I? Okay. Classic example. Imagine, Dylan, stand up.
Yes.
All right. You're going to have to imagine. Okay. Dylan is standing at the back of the room. Okay. Dylan's on Barnard's star. Okay. Now, Barnard's star. That's a star that is 5.9630 light years away. Okay. So imagine Dylan is a very, very clever bloke, and he's built this massive sign. Okay. He built a massive sign that says Dylan was here. Okay? So he's built this, spelled E wrong. You actually spelled was with a Z as well, so what's up with that? Okay, so Dylan's built this sign. Okay, then he hops in his faster than light spaceship. Okay, so he's travelling faster than the speed of light. Let's say he travels at twice the speed of light. So instead of it taking him 5.9630 years to get back here, it only takes him 2.5. Okay? Or nearly 3 years. So Dylan, wait, fly back over here. So it's taken him 3 years to get here. Now he's travelled quicker than light. Light is going to take 5.9630 years. He got here in 3 years because he's travelled with a hyperdrive. Okay? Now, like I said, he's a very intelligent bloke. So he builds this telescope. It takes him a year to build the telescope. This massive telescope which can see Barnard's star. Not only can it see Barnard's star, it's able to see people on the planets around it. Okay? So Dylan built this sign 3 years ago. He travelled here, got here within 3 years, then he took a year, he took 1 year to build it. So he's been gone from the time he built it there, 3 years to travel, 1 year to build, it's been 4 years. He still has to wait 1.9630 years before looking through that telescope will see him build his sign. The light from him building the sign hasn't got to us yet. He's already got back here and built the telescope so he can watch himself build the sign.
How will you see him when he's not there?
Yes, he is. He was there, and the light hasn't got here yet.
See?
We're looking at stars.
I just drew a picture of myself drawing.
There you go. It would be another year before
Mate,
he
could
could
you
watch
see
himself do
this?
that. You'd see yourself.
I'm done with
Because
that.
what you're doing is you're actually looking back in time. You're looking back 5.9630 years. Now that seems pretty cool. What's the
I like
furthest?
thinking about space.
The furthest star away from us is about 14, I shouldn't say 14 years, it's about 13.7 billion light years away, which means it takes light 13.7 billion years to get here.
This stuff freaks me out.
Well, what freaks you out even more is that's just after the Big Bang. It's the oldest thing we've been able to see. But there's a great one, Sirius. The dog star is Sirius?
Serious black.
Well, that's where they name the characters after, yeah. Sirius and Bellatrix, that's one of the other stars. But Sirius is going to explode.
Serious.
Yeah,
Serious.
any day now.
But we're not gonna know.
Yeah, we will.
So when it's insane.
Well, this is the thing. It's going to explode any day now. Now, Sirius, say, I can't remember how far Sirius is away, and this is embarrassing, but let's say it's 100 light years away. Okay? Sirius is 100 light years away.
We'll notice.
If we see it blow up, which we will, hopefully within our lifetime, if we see it go supernova, it will be the brightest thing in the sky for months, but it happened 100 years ago. It blew up 100 years ago. We're only just seeing it
Why
now.
do you always do this to us in maths?
Yeah. It's awesome. Okay, anyway,
Like astronomy tonight.
I love astronomy.
I like it, but
I don't
can't
like
cope
thinking
with
about it.
When we
I
do
just
this in
made it
science,
true.
and I
I
just
just
had
like-
we are. What about the regular test?
Well,
Like,
we still haven't worked out how far away this place is. We have to work out how far away this place is. Yes. But the thing is, you do not need to remember all these numbers. You just need to know how to manipulate it. Okay? And I'll show you how to manipulate it.
Come and do and say something.
Okay. Now, that is how many kilometres away it is. So that's how many kilometres that light travels in a year. Okay?
In bed.
Now.
Watch myself stand up there.
What we have to do is if we say that the star we want to look at is that far away, and that's how far one of them is, how do we calculate how far away it is? Yeah.
So does people watch themselves on the moon after
No, because light gets here too quick. It only takes 8 minutes to get from the sun to us. The only way you'd be able to do that is if you could travel faster than light. And physics says that's impossible. But the closer you get to the speed of light, the greater your mass. So as you approach the speed of light, your mass approaches infinity, which means you can't go any faster. So it's Einstein's theory says it's impossible, but they have discovered things that they call neutrinos that they think travel faster than the speed of light, and it's been postulated that they do, but they can't discover them yet because matter can't stop them. They go through things. Oh, I forgot 6. Okay, so 5.9630 times 9.4607 times 10. There you go.
You just got to remember that.
All you got to do is that.
Wait, I've got to write this down.
All you're doing is you're saying that I am 5.9. If I said you were 2 light years away, you'd just double that, wouldn't you? If I said you're 4 light years away, you just times it by 4. Well, I've said you're 5.9630 light years away. So you just times it by 5.9630. Okay? Now someone's going to put that into a calculator and they're going to give you an answer. And you need to be able to put it in exactly like this. And there is a button on your calculator.
Yes. With the X and Y.
There is actually a button there, if you have a look, above the log. It's a 10 with the number above it.
You can press one. Yeah.
Yep, there's another one down here which is your scientific notation one, which is gone AWOL. Where'd it go?
Next to the dog.
Oh yeah, no. So you can put in 5.9630 times
You covered it. I can't believe it.
9.4607 times 10 to the 12. Press equals and you get that.
Oh,
Guess what? It's already put it into scientific notation for you. 5.6
oh, shit.
414151 times 10, 13. Now the only problem is that's a big number that's really awkward to say. I want it to significant figures. Let's say, hey, 3 significant figures. What are your first 3 significant figures? 5, the 6 and the 4. Okay, so the rest of them we're going to say they're not significant. We don't need that much accuracy. Do I round up or do I round down?
Down.
That is a 1, so it rounds down. Does that make sense? If it was a 5, what would you do? Round up. If it was an 8, what would you do? If it was a 9, what would you do?
I'll do a leave one.
5.64 times 10 to the power of 13, 3 significant figures.
I just got
Everyone good? All you're doing is timesing it.